Okie dokie. Let's move along to example 3. Says the operations with rational numbers is the sum of two rational numbers always a rational number. Well, remember that a rational number, okay, so operation with rational numbers is just any number that can be written as a fraction of integers. Fraction of integers. So keep that in mind. So we're trying to see, is the sum of two rational numbers always a rational number? Well, let's just do some examples here. So let's go with two rational numbers. So for instance, 4/5 is a rational number, and we're going to add it to 3/10. Right? Those are both rational numbers. So you need a common denominator to add fractions. So 5 and 10, the common denominator is 10. So I'm going to take 4/5. I got to multiply 5 by 2, multiply 4 by 2. So 4/5 is also 8/10. That can be added to 3/10 now. So you do actually combine the tops. 8 plus 3 is 11. The bottom stays 10. So in this case, you had two rational numbers that got added together, and you got another rational number. So this example works. But this is just one example. We want to know if this will work for every number. So we're going to use variables. This might be a little bit whacked out for you, but we're going to go. We're going to go there. All right. So we're going to use A over B plus C over D. Here are two rational numbers. Okay. Well, to combine these, I need to multiply this first fraction by D and D, so that the D gets over here. I have to multiply the second fraction by B over B. So when I do this, I get A over D over B over D plus B over C over B over D. And that gets me my common denominator of BD. So I can add the tops like this: A times D plus B times C. That's all over B D. And the question is this going to be rational? Well, if you take two numbers, two integers, right, and multiply them together, you're going to get an integer. When you add them, you're going to get an integer. This top number is an integer. The bottom number is also going to be an integer because you're multiplying them together. Now, of course, B times D cannot equal 0. So if BD, you got to make sure it's not going to equal 0 because you can't have a 0 in the denominator. But this is going to be a rational number. So is the sum of two rationals always a rational number? Yes. Okay. Now this brings us to what they're trying to teach you, and it's this idea of what's called closure. So what we would say is rational numbers are closed under addition. I took a class in college called abstract algebra. We talked about a lot about closure. All right. So again, but there you go. So the book thinks it's important. They think you need to, be knowledgeable of this stuff. So there it is. And we're going to continue some of this. We have 3 more examples similar to this. All right. So buckle up. Okay. Here we go. B, is the product of two rational numbers always a rational number? So now we're going to do the product of two rational numbers, and is it always going to be rational? Well, let's do this example again using our two numbers. So 4/5 times 3/10. And if nothing else, this is a great review of how you do fractions. To do fractions, you need to just multiply straight across. 4 times 3 is 12. 5 times 10 is 50. Now this will simplify if you divide the top and bottom by 2, and you'll get 6 over 25. And notice that these two rational numbers, when you multiply them, gave you another rational number. So it works. So now let's apply it to our variable representations. A over B times C over D. Again, this time you just multiply straight across. So you get A times C over B times D. Again, integer times an integer is an integer. Same thing on the bottom. See, those are both integers. So yes, this is a rational number as long as B times D does not equal 0. So we're good there. So again, yes, it always will result. And again, we would say that the rational numbers are closed under multiplication. There you go. Okay, two more. So now those were both rational number examples. Now let's get into some other types of numbers. All right, so here you go. Example 4, operations with rational and irrational. So is the sum of a rational number and an irrational number a rational or irrational number? Oof, it's a lot to say, right? Well, let's talk about what an irrational number is. So remember, this is a non-repeating decimal. So we call it a non-terminating decimal. Non-terminating decimal. So for instance, like I said, the square root of 10, so any square root that doesn't simplify like we did, or pi. Pi is an irrational number. 3.14, blah, 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 blah. So we're trying to see, is the sum of a rational and irrational number, is it going to be rational or irrational? Right? What's it going to be? Well, let's take a look at an example, right? So let's use one of our numbers from the previous example. So let's use 4/5, and let's add it to the square root of 10. Well, when we do this, right, we're going to put the square root of 10 over 1, and we need to come up with a common denominator. So the denominator would be 5. So we need to multiply this one by 5, multiply the square root of 10 by 5. Now watch what happens. So the 4/5 does not need to change. The 5 goes in front of the square root. It does not get multiplied with the 10. Rules with square roots say you cannot multiply a number into a square root. So this would just be 5 square root of 10 over 5, because 1 times 5 is 5. And then when you combine these, again, because this 4 has no square root with it, you cannot actually change the 4. Like, can't go 4 plus 5 is 9. It's just going to be 4 plus 5 square root of 10 over 5. And unfortunately, because of this square root of 10, this is going to end up being irrational. So in this example, we saw that if we have a rational number and an irrational number, and we add them, you're going to get another rational number. Is that always going to work? Well, let's make an assumption. Let's assume that A over B is rational, and let's add it to C, which is irrational. And let's assume that we get an answer D over E. And let's assume that it's also going to be rational. So let's see how this plays out, okay? Well, what we can do here is we can isolate this irrational number by subtracting. We're going to subtract, watch this, A over B on both sides. So in a sense, we're going to combine the two rational numbers using subtraction. So the C is left alone, and over here we have D over E minus A over B. Common denominator, so again, multiply this by B and B to get the B over there. Multiply this by E and E to get the E over there. And here we go. So BD over BE minus AE over BE. And that's going to combine and get you, and I'll do it down here, BD minus AE all over BE. This, my friends, because you took a rational and subtracted a rational, right, as we did here, this answer is actually rational. And this is supposed to equal C. But wait. Over here, we started off with C being irrational, and now we got it to be rational. This is called a contradiction. This is a contradiction. When you say one thing and then do another thing, that's a contradiction. We said C is irrational, but when we did the work, we got a rational number for C. Therefore, C must be rational. Right? C must be rational. So this is a contradiction. I'm sorry. So the C is a C is a rational number. So that's our contradiction. So the answer is thus, this whole process, the answer is going to be irrational. So when you combine A over B, irrational, plus C, which is irrational, this answer D over E, this must be irrational. So the answer is irrational, as our example showed us. Sorry about the deleting of the work. You can always go back and see it. I wish I could too. I don't know if there's an undo button. Okay, all right, last but not least. So this is a mouthful, I know. So I apologize. Last but not least here. Okay, one more. So it says, is the product of a rational number and an irrational number rational or irrational? So same kind of idea here, right? Okay, so let's do an example. Let's use our same numbers. So 4/5 times the square root of 10. Again, we'll put that over 1. And now we just multiply left and right. Now, when you're multiplying, you can put the 4 next to the square root of 10, but not inside with it. So 4 square root of 10, and then multiply 5 times 1, which is 5. So when you took a rational and an irrational and multiplied it, the square root of 10 did not go away. So this is still irrational. So in our example, we got an irrational number. So the question is that always going to be the case? Well, let's see. Let's assume A over B, which is rational, times C, which is irrational, is going to equal D over E, which is a rational. Let's assume it's a rational answer. Well, again, let's get the C by itself. We're going to take both sides and multiply it by the reciprocal of B over A. This will get rid of the A over B. That'll isolate the C. And on the right-hand side, you'll have D over E times B over A. When you combine those, you're going to get BD times AE. And we talked about in one of the examples earlier that if you multiply two rational numbers, you're going to get another rational number. This result is rational. Well, this is what C equals, which means C must be rational. That's a contradiction right here. We said C was irrational. So there's your contradiction. So therefore, thus, the answer, we assumed it was going to be rational. We got a contradiction. That means thus the answer must be irrational, just like our example showed us. Now, there is one exception, right? Exception. If we were to multiply this irrational number by 0, right? So if A over B were 0, then you would get 0, because anything times 0. So if you did 0 times C, you get 0. Anything times 0 was 0. That's a rational. So this is the only example where you would get a rational answer. So the only exception, so your exception is if A over B equals 0, then it's going to be a rational, then rational. Okay. So again, I know that was a lot, right? That was a pretty intense second video. Do your best. It's just getting you into numbers again, getting you back into the swing of math, right? Okay. Great. Thanks for watching. We'll see you next time.